or anything, but we need to go ahead and get started on today's lecture. And yes, we're going to do lecture today. I'm hoping that if I can get through most of this lecture, we can move on to lab. But this is a very important lecture just because we're talking about the directional control valves. So having done the inventory on your trainers, you ran across directional control valves. You ran across a couple different types. You have the cam actuated, those are the ones with the lever arm. You have the push buttons and the switches. You had the pneumatically controlled ones. You had several. So we're going to talk about how those actually work and what they do. All right, so this directs the fluid flow to start, stop, or reverse direction of motion of the cylinders, motors, and other equipment we use. So that's pretty much why they're important, right? Because do we just want our cylinders going one direction? Or do we want them to be able to go two directions or however far we need them to be? So they can be operated manually or automatically by mechanical devices, electrical signals, compressed air, or hydraulic power. Literally, you can actuate them any way you need to. So, how do we identify them? First of all, we have what's called the way. The way is the number of ports. Generally, you have no more than 5, and you will never have less than 2. Okay? Because how they work is that you have to have some place for air or fluid to go in, and you have to have some place for it to come out. So there will never be less than 2, and there's usually not more than 5. Okay? So the first thing we identify is the number of ways, or the number of ports. The next thing we identify is by the number of positions. In other words, how many different ways can I switch it so that it'll do the job I need it to do? Okay. You have the type of control elements. So that's what's on the inside of these. What's on the inside of these, and what is it's used to control those ports. So you have a couple different ways we'll talk about, which are poppet, spool, or disc. The last thing we talk about, we don't really use that to describe them though. There's 3 things we need to use to describe these. The number of ways, the number of positions, and what is the method of operation. Some of you might have heard me telling y'all that something was an air actuated 2.5. I'm sorry, 5.2. Air actuated 5.2, which means it's an air actuated 5-port 2-position. Yeah. We'll talk about what all that means as we go. So manually operated. There's a lot of different valves that are manually operated. We see them all the time. We just don't always know what they are. Okay? So you have gate valves, glove valves, needle valves, plug valves, and ball valves. Jeez, I might have to stop saying valve here in a minute. Say that 5 times fast and you do not sound right. All right, so manually operated means that you, the operator, have to do something in order for something else to happen. Y'all were using one, actually, I'll take that back. Y'all were using 2 the other day in lab. You have the one above your head that you pull open, or push open rather. What does that do? It allows airflow, right? The other one is on your actual trainer. It's that little blue switch on your air source, where you flip it one way and it allows air into your whole system. You flip it the other way, closes it off, you can't get any air, right? Those are manual operators. Another example, push buttons. You get to push the button or you flip the switch. That's manual operation. Okay? So you have the globe valve, what this guy is. And what do you notice about how they operate, guys? You do have a manual operator, but it acts directly on your valve. Okay? All right. So we can operate them, automatically operate several ways. They can be self-actuated, mechanically actuated, electrical solenoid, pneumatic pressure, hydraulic pressure, solenoid, pilot. Let me put it this way. The way you operate something is how close do you want to be to it. So take in your garden, right? Everybody's been outside into the garden where you've got the hose, right? Where are you in the system that you're turning that hose on to get water? You're right at it, right? Now, instead of being right at it, let's say that you need to operate something on the other side of a whole factory, okay? Because the rest of the factory is a no-go zone because somebody could get hurt on something, something could pour down on you from the ceiling, whatever. You don't want to be up on that. So you're not going to use a manual actuator, right? You might use something that's a mechanical set. Or you might use a way of using air to push to it. Does that make sense? That's what automatically operated valves are for, is you don't want to be up on that to have to turn it on. You have to be able to do it remotely from quite a distance generally. Why? Because it keeps you, the human, safe. And that's always the biggest thing we want to do, right? We want to save the humans. Yeah, I know. All right. So there is a difference between direct and pilot operated. So pilot operated, how to put this? One of the more common ways to do a pilot operated is along the lines of let's see if I can draw this right. I will say my drawing skills are not always the best. I will go ahead and admit that now, guys. So when it comes to actually drawing things, I do like to have a reference. I'd like to be able to find the page I need here. There we go. All right, so pilot operated. You're talking something along the lines something that's going to look like that. There's a couple different ways that this guy can be operated. One of the ways you can kind of look at this would be a pressure relief valve. Well, how do those work? Anybody know? Yep. You can use them with air, but how do they work? What causes them to trigger? How about that? Pressure. What kind of pressure? Well, excessive pressure on your system. You generally got a way to set this guy. So let's say my system's normal pressure runs between 60 psi and we'll say 70 psi. We do have a range of pressures because when you're working with, let's say, hydraulics, you can end up with pressure differentials moving back and forth in the system. So you have to account for that at times. But if it gets up over that 70 psi limit, and yes, I'm being generous with that limit, but if it gets over that limit, you might have a problem with your seals once it does. So what you have are pressure relief valves. What those are looking for is for your system pressure to become too big, too much. And what it will do then is actuate this over so that it drains any excessive pressure off to the tank or vent it if it's pneumatic. Does that make sense? That's pilot operated, means that it's an automatic thing. It's not something that we'll have full control over. You don't come up and press a button or flip a switch. This is made to be its own device. It will trigger on its own whenever it's needed. Okay? Direct operateds are exactly what they sound like. They either have interaction with something that's going to be very closer to hand. What they're showing you here are solenoid valves. Anybody know what a solenoid is, first of all? It's magnetic, yes. So what you have is this piece right here is, I'm sorry guys, words are escaping me for today, so be patient with me. It's magnetized. So you have a north and a south set. The solenoid is wrapped in a wire, and whenever you add electricity to that wire, it's going to either cause it to extend or it's going to cause the solenoid to retract, depending upon how it's set up. Does that make sense? So that is how a solenoid works, for those of you that have not gotten to that part of electricity yet. Check valves. Now this is probably one of the most important types of valves. Okay. First of all, they're always a two-way, two-position valve. But the biggest part of this is that it only allows flow in one direction. Now, why might we want something like that? Yeah. So something won't get jammed up. Okay. Anybody ever hear of backflow? Or think about it like a balloon. Have you ever wanted to have something that you could put into a balloon that you did not end up having to fight it to keep blowing it up? You know what I mean? You sit there and you keep having to huff and puff, and every time you take your mouth away to get a good deep breath, what's it do? You have air escaping. So what you're dealing with a check valve is a way to keep air or fluid from going back the way it just came. It's a one direction valve. Okay? So you have what's called the cracking pressure with a check valve. What that means is that it's the lowest pressure required to open that valve. That's cracking pressure in general. It's not just applied to check valves. It applies to all valves. All right. And if any of you have ever taken robotics with me, you know what cracking pressure is. It's where instead of just absolutely taking a handle and cranking it open, right? What are you supposed to do? You open it a little bit. Yeah, you ease it open. Why? Well, because you can have all sorts of nasty crud in a pipe and not know it. To give you for an example, there was one time where I had a pipe that was leaking. I couldn't figure out why. So my dad took everything apart, and what had happened was inside the orifice of the valve was a little piece of metal, well, yet long, not the length of a finger, but it had gotten stuck in the valve. You couldn't turn the valve off. Now, it turns out that that came from the water company. Why? Because they had been working on the pipes outside. That happens all the time, guys. So in order to protect your pipes, in order to protect your valves, in order to protect everything, the best way you can ever open something is by starting to do it gently. Because if you crank it open real fast, you don't know what's on the other side of that. Does that make sense? If you've ever seen the disaster movies where they sit there and they open the door and all of a sudden something big just comes in and eats them, think of it that way. If you crank that sucker open, something big might come in and eat up your system because you don't know how much dirt is being carried in all the crud that you just let in. And what will that do to your pipes? Well, visually, you won't see it, but it'll start making deep grooves and scores in that pipe. What's that going to do over time? It's going to create a weak spot. It's going to eventually wear through, and eventually it is going to leak and crack open. So, yep, always be careful. So what you see here are a few check valves and how they work. This is how you're, and for those of you that have never really kind of thought about this, it's actually the way your heart is supposed to work. One-way valve. Sucks it in, moves it along. So what you have here are check valves. Like I said, they're a one-way valve. They allow flow one direction because that's all it should ever be in that one direction. Because if you flow back the other way, you might end up bursting a pipe or something. It's never good. Okay. A lot of valves have what are called spring returns. Now, why? Because springs mechanically work very well for this particular application. Springs have a certain amount of pressure that they put against your valve. So you have to overcome the pressure of the spring to open it. Lowest pressure that will open the check valve is what's called the cracking pressure, but again, cracking pressure can be applied to a lot of things. Mainline check valves can be used to reduce vibration and pulsation because flow only goes one direction. If it starts trying to go back the other direction or pulse, what's it do? It says, nah, you can't do that. For those of you that are electronics students, what is the device that allows this or mirrors this? I guess I should say. It's something we use very commonly in today's society. You find it very frequently in small electronic devices. And some of the most simple. Thank you. It is a diode. LEDs. You know those little LED lights everybody likes to use? They work exactly like a check valve. They allow flow of electricity in one direction. If the flow tries to go back the other direction, it blocks it and says, no admittance, move on. But it prevents air or sometimes even fluid from flowing back into, let's say, a compressor or to whatever you've got moving. So looking at these, everybody that's falling asleep and on their phones. Yes, I'm calling all of y'all out. What is wrong with this drawing right here? Knowing that flow can only go in one direction. It's a blockage. Why? Because your flow is literally shoving that ball into the orifice it comes out of. You're not going to get flow. It's just going to sit there. This is the proper way that a check valve would run. You can see what it would do. The pressure would push that ball back into its spring and keep moving. Okay? What about these? Same problem. You have one that'll run, one that won't. This guy will not run. All he will do is push pressure against those ball valves, closing the system. These will get to go to tank. That's what all fluid desires to do. Now, before we get too much further, I want to go ahead and make sure everybody's clear on what signs mean what. All right? When you're looking at symbols for hydraulics and pneumatics, there's two different ways. There's one main way we differentiate. With pneumatics, all right. So with pneumatics, the arrow that you see on any schematic should not have anything in it. Should be a clear arrow. Hydraulics should be colored in. Kind of makes sense since you're dealing with liquid versus air. All right? So that's the difference whenever you're looking at some of these symbols. So these would actually be hydraulic pumps pushing that fluid out into the circuit. So self-actuated valves are similar to check valves in that they have 3 or 4-way valves. They permit reverse flow, but only in certain directions. In other words, this is how a basic valve works. Okay? The one we have here is the shuttle valve, or the one I told y'all was an OR valve. Now, why do we call it an OR valve? Well, it takes this or this to move this ball out of the way so you can extend your piston. It takes lever 1 or lever 2 to allow operation of the piston. So that's an OR valve. It acts exactly like a check valve in the fact that if you actuate both, it can. If one's not more stronger than the other, it'll leave the ball in the middle and you don't get flow. But it will not allow flow to the other valve. That's the main thing you want to see here. You have flow coming in from one that is not going to go to the other, it's just going up to the piston. Does that make sense? So this is literally a shuttle valve. It's going to go either left or right, but you get an output in the end. So you have control elements. You have spool, which is one of the most common. You have poppet, disc, and rotary. What you mainly want to know is that the way these work is you have generally got 2 to 5 passages or ways that you're going to move fluid in and out of a valve. This one is showing you 4 different ways. So you have 4 ports. So you have from the compressor going out to valve out of port 1, and you have port 2 coming from its valve to the receiver or the tank. Okay? So this one's actually a 3 position. So first position, it's feeding from the compressor to side 1 of a, let's say a cylinder. So as that cylinder moves forward, it has to take all that fluid that's on the front side of that cylinder, all the air, and it's going to send it back out to where what they're calling the receiver. Could be exhausted, wherever you want to send it. Position B is where you're going to see it go from the compressor to the other side of your piston, and from one it goes to the receiver. Okay? And then you have what's called the neutral position, where nothing goes anywhere. It all just kind of sits there. Okay? So a two-way, two-position, normally open valve. This is why you can use one of them. This one's a manually operated. How do I know? Because this is a little push button they're showing you right here. So in position 1, it allows flow in and out. But when you actuate it to the other position, it stops it off. Okay? And then once again, you have the hydraulic version versus the pneumatic version. So one of the things you're going to be learning with a lot of this is exactly how to draw a lot of this. Okay? We're going to talk about that when we get there. So this is the way a spool works. You have it shifting 3 different ways. You have the neutral position, which, as you can see, blocks everything off. You shift it one way, you allow flow from P to B. Shift it the other way, P to A. But B vents to tank, or A vents to tank, depending upon which way you've got it actuated. Okay? So these are some different ways for 3-way valves. It can be used to keep a load raised or lowered, depending upon what you need it to do. Okay? So what you should see is that you have between 2 to 3 different positions with these. And you see a lot of spring returns because, again, the spring is a typical favorite. Now, I will say this because it is a test question and you might want to know it. You see a spring on either side of a valve. It means that A, it's got 3 positions, and B, it is what is called spring centered, which means that when no pressure is applied, it goes to your center set as your main way you're supposed to see the valve, or the main way it's supposed to live. Okay? Everybody following so far? Okay. So what you have right here, when you have 2 springs on either side of a valve, or a valve drawing rather. First of all, you have the middle position. That is going to be the neutral position, because whether you actuate it left or right, once you relieve pressure off your actuator valve, off your manual actuator, these guys are just going to spring it back to the center position. Okay? That also indicates that you will always have 3 different positions you can put the valve in. You have 3 positions you can put the valve in, and it is what is called spring centered. So you're going to have it sit to that middle position every time you release it. Spring centered. Oh, I say it's a test question. Everybody perks up. All of a sudden, everybody looks up and goes, "Oh, test questions." Figured that'd wake everybody up. What? Everybody have a big lunch and figure Forget you had class this afternoon? But it is what is called spring-centered. So here's a good example of it. So this is a manual actuator. If you push it one way, it's going against the spring. If you pull it, it's going against the spring. Once you release hold of it, it's going to go back to its center position. So it's got 3 positions, and it is what is called spring-centered. It's actually very typical of a 3-position valve to be spring-centered. Everybody good? So 4-way, 2-position valve. So what I want y'all to see is this little drawing right here, the one on the right. Now what I want y'all to see is that this is the very basics of drawing one of these valves. Okay? What you're seeing is a way to draw it so that it is understood by others that are going to be looking at these. Okay? So the very first thing you start off with are these boxes. Okay? One box, one position. Okay? Each box is a position. So if I have a 2-position valve, I've got to draw 2 boxes. Okay? Secondly, if you're trying to determine the number of ways or the number of what? Ports. The number of ways is the number of ports. In other words, how many entrances and exits does it have? And yes, that can also be a test question. The way you determine the number of ways is looking at either one of these boxes. How many times does it have something touch the edge? Okay? So how many times is something touching the edge of the box? In this case, we have 4. You have 1 here, 1 here, 1 here, and 1 here. So it goes from 1 to 2 and from 4 to 3 in this particular box. What that means is that 1 is always going to be your pressure. 1 will always be your incoming pressure. Always. Period. End of. Okay? 4 and 2 will always be your outputs. Okay? 4 and 2 will always be outputs. And 3 typically 3 and 5 are typically exhaust ports. Meaning that they're either going to go to tank if it's hydraulic, if it's pneumatic, you're going to have a silencer somewhere and it's going to be venting air like crazy. Okay? Those are the normal functions of your ports. Evens, your 2 and 4, are always outputs. 1 is always your input. 3 and 5 are exhaust. Does that make sense to everybody? Okay? 1 is your input. 2 and 4 are your outputs. 3 and 5 are your exhaust. So you will always have an input. So you should always have a 1. And you will always have an output. So you should always have at least a 2. That's why there is never less than 2 ports or 2 ways. follow? Everybody good? Okay. Like I said, each box represents a position, and the number of times it touches the edge of that are your ports, otherwise known as ways. Okay. So in this case, this one is a 4-way 2 position, or a 4-2. Now, why do we want to shorten it like that? Well, because it makes it a lot easier to tell somebody I need a 4-2 than you need a 4-port 2-position valve. It just shortens it up, makes it faster. All right, this one's another 2-position 4-way. So the way you should see this working, if you had this actually in field, you have pressure coming in on your P. This would also be labeled 1. It would be coming out at 2. It's going to drain at 4 and go to 3. Okay? So 1 will put pressure, initial pressure to 2, forcing your cylinder back. At the same time, the pressure or the air, the fluid, whatever is on the back end of this is going to be dropping down from this way to 4 and going to 3. Okay? Now, when I actuate it the other way, my pressure will then be going to 4, causing my cylinder to push out. The fluid, whether it's liquid or air, is going to come from the front of this cylinder down to 2, and then it's going to go out this way to my exhaust. Everybody see that? Any questions on that? All right. All right, so looking at this next one, these are extremely common. And that is what's called a 3-position 4-way, or a 4-way 3-position, depending upon which way you're working with it. Verbally. Okay. What I don't like about it is that this is showing a 5-way up here in this picture. I don't think the person that drew the book was thinking it through that day. It happens, right? Everybody's got their own thing. So the normal position, because 9 times out of 10, I won't say that. Frequently, you will have these guys, these 3 positions. Generally, you have 3 positions be spring centered. So this would be your main position. Everything sits in until you actuate it, in this case manually. When you actuate it to this point, you're going to see your pressure go to B. Your pressure will come back through A and should go to your exhaust. Okay? When actuated the other way, you'll see pressure goes to A and B will drain to exhaust. It's a fairly common way for that to work. If you move it to the right, pressure will go to B. If you move it goes to A. If you're watching, one of the things you might do, looking at these initially, is just come in and put P, E, A, B. And the whole reason you would do that is just as a visual reminder. If you can ask anybody that's ever had a class with me, I like visual reminders, don't I? It makes life so much easier. You don't have to stop and think about it as hard, or try and cope with it as hard. Because some of this stuff does get confusing. Visual reminders do help. They're my favorite way to deal with it. So then you have the five-way, three position. So these are more common in pneumatics and hydraulics. Why? Because with hydraulics, we're not looking to exhaust anything. Okay? Most of the time when we're dealing with hydraulics, you'll see a four-way, three position, or a four-way, two position. The biggest thing with hydraulics is that we have to drain it to tank. Okay? Think about what would happen to your vehicle if instead of draining everything back to your oil pan, you just threw it out into the world. That'd get kind of messy after a while. Not to mention expensive, right? Well, same thing with this. You have to be able to get it back to tank pretty well. Otherwise, it will get pretty expensive pretty quickly. So with pneumatics, we don't have to care as much about what we do with the byproduct of what we use. Generally because we've already used it and it's nothing but air. Since it is nothing but air, we exhaust it. We can just push it out into the world, say bye, where we're probably going to end up being sucked back into a compressor and used again. Okay? But on the off chance you do find a five-way, chances are you're getting either two different sources or your exhaust goes to someplace else. Or instead of both going to tank, one's probably going to end up going to some other mechanical device, probably as a pilot valve. So you have a lot of symbols. You'll find these in your fluid power data book. You'll find it in your actual book. Okay? The ones I kind of want to go over are these right here on the right. Because this is what is called a combination symbol. Okay? Now, the way we've already combined it in our labs is by an open triangle, right? Clear triangle, working with pneumatics. But that triangle can be doing a lot. Okay? Actually does a lot. Because it does the first and foremost what we have inside our trainers is an air filter, a regulator with a gauge. And a lot of the times what you'll see on most pneumatic equipment is a lubricator of some sort. Because when we pull air in, we tend to dry it out as we compress it. Because two things happen when we draw that air in. A, we're sending it through a filter, which hopefully is picking up some of the humidity we have down here. That is picking up some of the humidity. But it also is, when you compress air, you tend to push out all the water. The problem with that is in your compressor tank, you have to drain it periodically. If you don't, you can get quite a bit of water in there. Water in a metal tank. Anybody think that's a bad idea? Rust will happen first. Air doesn't mind being compressed. It's not hydraulics. But what you're going to mainly have an issue with is rust. And that is something that happens far too frequently with compressors. If you really look at a lot of the really old compressor tanks, they're pretty rusty. So what you have is air being dried out through compression and filtration. And that's good because we do not want water in our system ever. It wreaks havoc like crazy. So what do? We filter it 7 ways to Sunday. However, dry air is not great for components because it takes all the moisture away from those components. So we have what's called lubricators. Those lubricators add oil in a very fine mist spray to our pneumatic systems. Okay? With the purpose of it being used to keep the parts from binding, at the very least, is what will happen with it. Y'all know what binding is, right? It's where metal touches into metal and it likes each other. So thus it does not let go easily. Right? And once it does that, it's going to take a lot of oil to get it to let go. So the most common symbols in these, excuse me. All right, you have your filter. You can have mist separators, but they're not ones that we use here. But you'll see a filter, you'll see a regulation unit with a gauge, and on some units you will definitely see what's called a lubricator. Again, all that does is take oil, a very light, fine oil, and mist it into your system so that it lubricates everything downstream. So what you see here are symbols for different actuating devices. Okay? So we already talked about our boxes being our positions. Every time the edge of it is touched, that's a port or a way. Now we have to describe them based on what makes them move. And we can move them just about any way we want to. You have the hand levers or push buttons. You have cams, solenoids, springs, pilot valves, buttons, foot pedals. And you have what's called detents. Now, detents are generally combined with either a switch or a button. And matter of fact, we've got switches that have detents. We have a push button, the yellow block with the red button. That's an e-stop. What a detent does, okay? What a detent does is in operation, it's going to lock in. So at some point, if you push this way, it'll lock into this groove. It'll lock into one of the grooves that you're trying to use. That is a detent. It means literally locking it in place. All right? Does that make sense? Because I will guarantee you, a lot of you will look at it and go, what's a detent? It means that it locks in place. Okay? So this one is a solenoid pilot operated valve. So in other words, all it really means to be pilot operated is remote operated. Okay? And it also means that it can actually actuate itself. 5.2 or a 5.3. Can't really tell based on the drawing here because the way it's going to actuate is it's going to end up pushed against this spring. In its normal position, when you push back this way, the A goes there. That's your pressure line. So I believe this is a two-way. I'm sorry, a two-position 5-way. Now, one of the things I've kind of done around the edge over here is I've got some of my valves out if y'all want to look at them later. But these are some different ways that you have valve operators. Now, the one that's the black and gray right here, he's a solenoid. How do I know? Because that's a plug. Quite literally, that is a plug. That's what's going to operate your solenoid. It's got a plug on both sides. So he is solenoid actuated on both sides. Y'all see that?
Question.
Answer.
Don't you have like some of those have wires that you plug up to?
Some of them can.
When you plug into the valve.
With most, trying to think of how to answer that. There is no truly typical anything. There are standardized things, but you can get specialty anything. Does that make sense? So that's why I'm always reluctant to say, yes, you will always see it this way, because generally, no, you won't. It's going to depend upon, the age of whatever it is you're working with. You know, if it's 50 plus years old school people had a different way of doing things. We've all seen it, right? If you look at older houses, most of them were fused, not circuit breakers. Today, you would never get that passed. So that's why I get so reluctant to always say always or never on anything, just because it has a bad habit of proving you wrong. Matter of fact, guys, if y'all ever see the words always or never on a test question, read it very carefully, because generally the answer is no, that's not true. Why? Because absolutes are a really hard thing to find in the world. And that is a true absolute. Does that make sense? So that's why I'm very reluctant to ever use absolutes, just because there really cannot be an absolute to this. Yes, you could end up with that directly wired to something. As a manufacturer, I think it would probably be easier to generate something with a plug. Why? Because then all you have to do is plug it in on both sides. If the customer has to change it out later, just unplug it, plug a new one in. Ta-da! So, like I said, it's kind of why you're asking wires. I'm sitting here. Okay. Where was I? Oh, yeah. Okay, so this is a double solenoid actuated valve. You have a manual hand lever, you have a push button, and you have a cam valve. Now, the cam valve can be used a couple different ways. One way it can be used is actually as almost like a counter. You can actually hook these things up to a counter, so it can count up however many things that you need to, because counters are pretty much a norm in manufacturing. Why? Because we kind of like to know how many things we made that day, right? For some odd reason. I don't know why they want to keep track of that. Okay. All right. This actually, we have another picture of this. I believe it's on the wall somewhere here. We recently hung those up. They're kind of interesting to look in bigger view of it. So what you're looking at here is a 4 flowed circuit. For those of you that do not know, the dotted lines that are around these four right here means that they're all part of one device. That's what I'm trying to say. It's all part of one device. Same for this one. So this right here, you would be looking at a filter pressure regulation unit with a gauge, all on one unit, all part of one unit. For these three right here, you're looking at four position. I'm sorry. You're looking at two-position, four-way, push button controlled. These all actually have solenoid control as well. You have a springer turn on this one. And that would describe those valves. And again, this would all be part of one unit. Okay. What you have above them are something that we're going to talk about at some point. Those are pressure regulator. Right now my brain's not holding that name. Sorry guys, literally I'm scrambling on that name for some reason. All right, it is a it's a flow control valve with bypass. This is a flow control valve with bypass. I'm sorry, I could not come up with the name for it for a second there. So what this allows to do is there's certain ways we like to control pressure and speed of our cylinders. One of them is to control the flow in and or out of the cylinder. So what I'm looking at here, I'm going to tell you is what is called meter out. Because what I'm looking at is when I apply pressure, it's going to go through the check valve. But what I'm controlling is what's coming out of my cylinder, because it can't go through that check valve. Instead, I let it out very slowly, so the pressure takes more time to push that cylinder back. Because what it's doing is fighting the pressure of the cylinder emptying. Does that make sense? And it would work the same way the other way. If I put pressure on this line and move this guy out, what I would see is he would move out very slowly, because while pressure is being applied back here, the pressure up here is being let out very slowly. It takes a very long time for that pressure to leave. Does that make sense? All right, we've got a vacuum generator and two other cylinders. Meter out is probably one of the most common assemblies of these. Why? Because it means that we can keep the cylinder moving in a very smooth way. Because you have control over how fast the air leaves, you also have control of how fast it can enter. So it's very smooth. Once it starts moving, it's just very easy to go. We'll talk more about that when we get to that. All right. Try and move through some of this. All right, so we'll go ahead and stop that there and come back